You can join two inequalities with the word and or the word or to form a compound inequality. To solve a compound inequality containing and, find all values of the variable that make both inequalities true. Problem 5. Solving an and inequality. What is the solution of 7 is less than 2x plus 1 and 3x is less than or equal to 18? Graph the solution. Well, consider the inequalities separately and solve them separately. 7 is less than 2x plus 1. Using inverse operations, we can solve this as 3 is less than x. And on the right-hand side, 3x is less than or equal to 18. Simplifies to x is less than or equal to 6. So we have these inequalities, 3 is less than x, and x is less than or equal to 6. Consider them graphed below. First, the red inequality at the top, 3 is less than x. Note the open circle at 3, our boundary point, arrow pointing to the right to indicate all values greater than our boundary point, our solutions. And then the blue graph of x is less than or equal to 6, a solid boundary point at 6, and an arrow pointing to the left to indicate the values less than our boundary point. It's the overlap of these graphs that represent the values that satisfy both inequalities. And because we have the word and involved in this compound inequality, that's what we're interested in, the values that satisfy both inequalities. So that's represented here in purple, with an open circle at the boundary point 3, a solid circle at the boundary point 6, and a line segment connecting the two. Keep in mind, and means that a solution makes both inequalities true. You can rewrite an and compound inequality, such as 3 is less than x and x is less than or equal to 6, in the form, arguably the simpler form, 3 is less than x is less than or equal to 6. You read that inequality as x is greater than 3 and less than or equal to 6. Or you could read it the way I just read it. 3 is less than x, which is less than or equal to 6. Your turn. Part A. What is the solution of 5 is less than or equal to 3x minus 1 and 2x is less than 12? Graph the solution. And part B, a reasoning item. Is the compound inequality in problem 5 always, sometimes, or never true? Explain your reasoning.